In this question, we're told that n is an integer greater than 1, and we need to prove algebraically that n squared minus 2 minus n minus 2 all squared is always an even number. And so the first thing that we need to do is to acknowledge that an even number is always divisible by 2. So let's start. So now we can start by simplifying the expression given to us. We have n squared minus 2 minus n minus 2 all squared. So let's write that out as n minus 2, n minus 2, which is the same as n minus 2 all squared. So now let's focus on the double brackets, and we can use Moon method to simplify this expression. N squared minus 2 minus, and then we have n multiplied by n equals n squared, and then we have n multiplied by minus 2, which is minus 2n, then n multiplied by minus 2 again, we have another minus 2n, and finally we have minus 2 multiplied by minus 2, which is plus 4. So now we need to be really careful with this minus over here, because we can't just say n squared minus 2 minus n squared minus 2n plus 4, because the minus changes the sign. So let's simplify the expression for the double brackets first. We'll say n squared minus 2 minus n squared minus 4n plus 4. And then we can now say that n squared minus 2, well, we could imagine here that there's minus 1 in front of this, which will help us when we simplify the expression. Minus 1 multiplied by n squared is the same as minus n squared. Minus 1 multiplied by minus 4n is the same as plus 4n. And then minus 1 multiplied by plus 4 is the same as saying minus 4. So now let's simplify this again. We can collect the like terms. N squared and n squared are like terms, while n squared minus n squared just simply cancels out. Then we have minus 2 minus 4, which is the same as minus 6. So we're left with 4n minus 6. We have the 4n over here, that's untouched, and the minus 2, take away 4 is the same as minus 6. So now we're left with 4n minus 6, and we can say that n squared minus 2 minus n minus 2 all squared equals 4n minus 6. But how do we prove that this is always even? Well, we mentioned that an even number is always divisible by 2. And so to prove that an algebraic expression is even, we need to be able to factor 2 out. So if we take 2 out of this expression, we're left with 2 multiplied by 2n minus 3. And we can see that we've managed to factor out 2, which proves that this is even. But we're not quite done, because we need to have a statement at the end of our working which clearly shows this. So we can say that n squared minus 2 minus n minus 2 all squared equals 2n minus 3. 2 multiplied by 2n minus 3 is a multiple of 2, and therefore n squared minus 2 minus n minus 2 all squared is always an even number. This question is worth 4 marks, and so to get the 4 marks, the first mark is for the correct expansion of the brackets, which we've done over here. We've got n squared minus 2n plus 4, which simplifies to n squared minus 4n plus 4. That second mark is to arrive at n squared minus 2 minus n squared plus 4n minus 4. The third mark is for reducing this to 2 multiplied by 2n minus 3, which we've done over here. And then finally, that last mark is for that conclusive statement which states that 2 multiplied by 2n minus 3 is a multiple of 2, and therefore n squared minus 2 minus n minus 2 squared is always an even number.